Hello students, in this video I want to explain about what are the compounds prepared from the common salt. Okay, let us take the common salt first. Okay, what is the chemical name of the common salt? The chemical name of the common salt is sodium chloride. Sodium chloride. Sodium chloride formula NaCl. NaCl. Sodium chloride. It is an ionic compound. In between that, sodium cation and chloride anion, there is the electrostatic force of attraction is there. This is nothing but the bond is called, that attraction is called ionic bond or electrovalent bond. Okay, or electrostatic bond. Okay, anyway, so the sodium chloride is an ionic salt. It is soluble in water. You know that all ionic compounds are soluble in polar solvents. What is the example for polar solvent? Water. So NaCl soluble in polar solvent. Now, this is called table salt or common salt. Generally, where we use this? So salt is used in cooking food. Okay, in every food item compulsory salt required. Without salt, no taste. Okay, in curries or so many food items. Okay, and to preserve that fish, dry fish or pickles, to make the pickles, and in so many, okay, in so many things we are using this salt. Salt is very, very important. Now, what are the sources of salt? Source. Okay, the number one source is seawater. Seawater. And the second source is rock salt. Okay, number one, seawater. So they will take the, if you go to the beach, there salt meadows are there. Salt meadows. So in that they pump the seawater into the salt meadows. Okay, salt meadows means a shallow, less amount of water in that field. Okay, due to the sunshine, sun's hot, what happened? This water is evaporated. When this water evaporated, what leaves there? Salt. Okay, large amount of salt is leaving. So they will gather that salt and they collect it and they purify that salt and they use for cooking and different purposes. Okay, so that is the one source. Another source is rock salt. You will get the salt. How you are mining different metals, different minerals. The same way you can mine the salt also. In some places, rock salt is available in the earth crust. When you dig the earth crust, there is a lot of salt deposits are there. How these deposits are formed? In bygone ages, in ancient days, what happened when the oceans are dried up? When the oceans are dried up, it leaves salt. If you go to the Dead Sea, did you see that if you go to Dead Sea, a lot of salt is there beside the bank of that ocean. Lot of salt. Why? Because when anything is drying, the salt water is drying, it leaves that salt. Okay, these are the two sources to get the salt. NaCl. Salt means the only thing that in chemistry, salt is a general name. General name of anything. Salt means any ionic compound, any crystalline compound is a salt simply. Okay, but we have to mention that here NaCl, we are studying about the sodium chloride salt. Sodium chloride salt. Let us, now what is my question is, okay, compounds prepared from common salt. Now we learned the common salt formula and sources of this common salt. Next one is, what are the compounds prepared from the common salt? From this common salt, we will prepare different compounds. From this, we will prepare different compounds. Number one is NaOH. NaOH, sodium hydroxide. Number two, bleaching powder. CaOCl2, bleaching powder. Number three is NaHCO3. That is called baking soda or sodium bicarbonate. Number four, Na2CO3. Na2CO3, 10H2O. This is called, only Na2CO3 is called soda ash, which is used in glass industry. Na2CO3 is called soda ash, generally sodium carbonate. Na2CO3, 10H2O. This is called washing soda. Washing soda. Chemical name simply sodium carbonate only. Both. Sodium carbonate. These are the main compounds prepared from the common salt. Once again, what are the compounds prepared from the common salt? Number 1, sodium hydroxide. This is called caustic soda. Number 2, calcium oxychloride. This is generally called bleaching powder. Number 3, sodium hydrogen carbonate. This is also called baking soda. Number 4, NaCO3 10H2O. This is generally called as washing soda. These are the different important industrial compounds we are getting from that one salt. The salt name is sodium chloride or table salt or common salt. Now let us study that the preparation of these compounds one by one. Okay. Now let us take the first one. What is the first one? Sodium hydroxide. How to prepare the sodium hydroxide? The first one is sodium hydroxide, NaOH. Sodium hydroxide, common name is caustic soda. Okay, why? Because it reacts with our proteins. It reacts with our skin proteins. Okay, and it is corrosive nature. It corrodes easily. That's why it is called caustic soda. And next, how to prepare this? To prepare this, first we have to take the sodium chloride aqueous solution. Sodium chloride aqueous solution. The sodium chloride, when sodium chloride dissolve in water, that is called aqueous solution of sodium chloride. Okay, salt, that NaCl salt we have to dissolve in water. Prepare the saturated solution. This solution is called brine solution. What is that? Brine solution. What is brine solution? NaCl in water. That is called brine solution. Okay. So take this brine solution and in presence of electricity. So we have to pass the electricity. To pass the electricity, simply we can't pass now. They have a tub, so the electrolyte and all these things, cathode, anode, wires, battery. So all this required. So what I am taking, I have taken that. So what is electrolyte here? Sodium chloride aqueous solution. This is called, the total is called brine solution. What is this? Brine solution. Take the brine solution. Okay, by using electrodes, if you pass the electricity. Okay, if you pass the electricity, simply just I am taking one diagram here. For example, this is a tub. So I am taking here sodium chloride or brine solution. I am taking here. So middle I arranged one semi-permeable membrane. A membrane is there, and here. So this is, for example, one electrode. This is another electrode. Okay, and for example, if it is the anode. It is the cathode. Okay, cathode, anode. Sorry, this is always negative electrode is called cathode. So positive electrode is called anode. When you pass the electricity, what happened? Here, what is there? NaCl is there. NaCl. Next, what is there? H2 also present. When NaCl decomposes in presence of electricity, it gives that Na plus and Cl minus. Whereas H2 also decomposes in presence of electricity, it gives the H plus and OH minus. Now you have to understand carefully. Okay, towards the negative electrode, which ions are migrates generally positive ions. So who are the positive ions here? H plus and Na plus. Now H plus is moving this side, and at cathode, which gas liberated? Here, which gas liberated? Hydrogen gas liberated. At cathode, this is the cathode. At cathode, hydrogen gas liberated. And Cl minus is the negative ion. It is moving towards the anode. This is the anode now. At anode, which gas we can collect? The chloride ions are moving here, and we will get here chlorine gas. What is that gas? Chlorine gas. Okay. So when you pass electricity at cathode, you will collect the hydrogen gas. At anode, you will collect the chloride gas. Okay, but our purpose is to preparation of the sodium hydroxide. Now what happened at the bottom? So the bottom also near to the cathode. Near to the cathode only. Which one is formed? NaOH, sodium hydroxide. So in this electrolysis of brine solution, it gives three products. One is sodium hydroxide, second one hydrogen gas at cathode, and third one chlorine gas at anode. That you have to remember. So that's why this process is called, which process? The electrolysis of brine solution. This process is called chlor-alkali process. What is that? Chlor-alkali process. Chlor-alkali process. In examination, you will ask that what are the main products in chlor-alkali process? You will ask what are the main products in the chlor-alkali process? NaOH, hydrogen and chlorine. These are the three main products. And one more question he is asking: why we are calling this the electrolysis of brine solution is called chlor-alkali process? You will ask. So electrolysis of brine is called chlor-alkali process because in this alkali, which is alkali? NaOH. NaOH is alkali. So here alkali produced and chlorine gas also produced. That's why it is called chlor-alkali. Chlorine gas is called chlor. Here is alkali. That's why this process is called chlor-alkali process. Got it now? So this is very important. And after that, so we have to study about that uses of these hydrogen, NaOH and chlorine gas. So uses I will teach at a time in one video. So now I am going to that preparation of next compound is calcium oxychloride or bleaching powder. Bleaching powder formula CaOCl2. Bleaching powder. Okay, bleaching powder. How to prepare this bleaching powder? So in the previously at anode, which gas liberated? Chlorine gas. That gas is we are using to prepare the bleaching powder. So what are the raw materials to prepare the bleaching powder? First we have to take the CaOH taken twice. Dry slaked lime. Dry slaked lime we have to take. Take the dry slaked lime. So pass the chlorine gas. Pass the chlorine gas. From where we get the chlorine gas? From that chlor-alkali process. Okay, pass that chlorine gas through the dry slaked lime. Dry slaked lime, calcium hydroxide. So then what happened? It gives that CaOCl2 plus H2O. This CaOCl2 is called bleaching powder. CaOCl2 is called bleaching powder. The preparation is very important. Okay, here the preparation is there now. The preparation of the bleaching powder, chemical reaction, very important. Very simple. Take dry slaked lime, pass the chlorine gas through it. Then it gives the bleaching powder and water. Okay. So this is the preparation of the bleaching powder. Next, I am going to that another one, the third. So what are the uses of the bleaching powder? General, simply. So bleaching powder is used in textile industry, paper industry, and domestic purpose also we are using, and to use that to kill the germs in water. Okay, for water treatment also they are using this bleaching powder, and it is one of the good oxidizing agent. Okay, one of the good oxidizing agents. These are the applications of the bleaching powder. So next, third one. What is the third one here? The third one is NaHCO3. NaHCO3. How to prepare the NaHCO3? What is the normal general name is baking soda. Baking soda. Okay. baking soda or sodium bicarbonate. So when you take this, so here first we have to take the NaCl plus water. NaCl plus water is called brine solution. To this brine solution, we have to pass the CO2 gas and pass cold NH3 ammonia. Okay, NaCl, water, carbon dioxide, ammonia. These are the reactants. To brine solution, you have to pass the carbon dioxide, then pass the ammonia gas. Then it gives. Okay, it gives that NaHCO3 plus NH4Cl. Baking soda and ammonium chloride. Ammonium chloride. These are the two products. So, what is the preparation? When you pass the carbon dioxide and ammonia through the brine solution, it gives that baking soda, sodium hydrogen carbonate, and ammonium chloride is formed. So, this is the baking soda. Now, when you take this baking soda, okay, if you heat the baking soda, NaHCO3, it gives Na2CO3 plus H2O plus CO2. So when you heat the baking soda, we will get the sodium carbonate, another compound, very important industrial usual compound, and water, carbon dioxide. Okay, these are the products formed. Okay, this carbon dioxide is used to make the cake spongy and fluffy. Got it now? So this. Next, what are the applications of baking soda? Baking soda is a mild non-corrosive base. Baking soda is the mild non-corrosive base. That's why baking soda is used in antacid tablets. Antacid medicine is there now to get rid of that excess acid. Okay, acidity problem. They are using this baking soda. Okay, baking soda is a basic salt. Its pH is greater than 7. Okay, so now let us see some applications of this baking soda. Okay, one application is it is used as the antacids. Okay, and the second one is it is used in the soda acid fire extinguisher. Nowadays, no soda acid fire extinguisher we can't see, but in olden days, soda acid fire extinguisher is there. In that soda acid fire extinguisher, so you know that a cylinder is there. In one compartment, okay, in one compartment acid is there. In another compartment, what is there? In another place, so baking soda is there. So when you mix these two, immediately when carbonates and bicarbonates react with the acid, it gives that carbon dioxide. That carbon dioxide is utilized to extinguish the fire. So number one is in antacids, number two is in it is used as a fire extinguisher. Third one is in antiseptics also they use this baking soda, and fourth one is to prepare the baking powder. This is very important. Let us see that. So I will write the chemical equation here. To prepare the baking powder. So what is baking powder? Baking powder is the mixture of baking soda. Baking soda formula NaHCO3 plus a mild acid, a mild edible acid. H plus means acid. Why? Because acids gives H plus ions. That's why simply I am taking that one acid. Which acid? Strong acid? No. Mild edible acid. Mild organic acids we have to take. Okay. So for example, tartaric acid, baking soda and tartaric acid. The mixture is called baking powder. This is called baking powder. Okay. The combination of these two are called baking powder. Okay. So when we add this baking powder to dough, so what happened? Carbon dioxide is released. So it gives that. So it gives when we add the water, it gives generally CO2. It releases the CO2 and next some other sodium salt is formed. Okay, like that something, but the carbon dioxide is formed here. Carbon dioxide is formed. So this carbon dioxide is the main reason for the spongy or fluffy nature of the cake or bread. Okay, so this is about that baking powder. Now, what is the formula of the baking powder here? Baking powder formula is baking soda plus edible acid, that is called baking powder, that we have to remember. Okay, so next and fourth one is washing soda. So how to produce the washing soda? So to prepare the washing soda, I want these two chemical equations. Okay, to prepare the washing soda, we can't prepare the washing soda directly. We can prepare the washing soda from the baking soda. First, we have to prepare the baking soda by using the sodium chloride. Sodium chloride, water, carbon dioxide, ammonia gives the baking powder. Now take this baking powder. When you heat this baking powder, when you heat it gives that sodium carbonate. And now this is called soda ash. Soda ash. Sodium carbonate, water, and carbon dioxide is formed. Now take this Na2CO3. Okay, Na2CO3, dissolve in water. Okay, prepare a supersaturated solution and leave aside. So what will happen? You will see that the sodium carbonate, okay, absorb that water and it forms that sodium carbonate 10H2O. So Na2CO3 plus 10H2O, that gives Na2CO3 10H2O. This is called washing soda. Washing soda. This is called washing soda. Okay. This is called soda ash. No water molecule in it. Now, when we recrystallize in water, this Na2CO3 gains 10 water molecules. One molecule of Na2CO3 gains 10 water molecules and gives that Na2CO3 10H2O. This is called washing soda. Washing soda mainly, okay, we are using in domestic purpose. In olden days, no detergent. Washing soda is the best detergent in olden days. So domestic purpose, cleaning purpose we are using. And second one is, it is used to remove the permanent hardness of the water. And the Na2CO washing soda, this Na2CO3 is used as the what is that? So borax, sodium compounds, so borax, to prepare the borax. Okay, and Na2CO3 is used in glass industry, paper industry, and some other industries. They are using this washing soda. These are the uses or applications of the washing soda. Okay, so these are the four compounds prepared from the common salt. What are the four compounds? Number one, sodium hydroxide. Number two, calcium oxychloride, bleaching powder. Number three, NaCO3, that is called baking soda. Number four, Na2CO3 10H2O, that is called okay, washing soda. Okay, now the second part, next one is, I want to explain now, and another compound, that is plaster of Paris. Plaster of Paris is not prepared from the common salt. Okay, before going to the plaster of Paris, I have to explain one important concept: hydrated salts. Hydrated salts. Let us take that Na2CO3 10H2O, Na2CO3 10H2O, and the second one is CuSO4 5H2O, and third one is CaSO4 2H2O, and so on. Next, fourth one is MgSO4 7H2O, fifth one FeSO4 7H2O. So like this, if you take salts, okay, the salts are hydrated. That means the salts contain some water molecule. Every molecule of the salt contains okay, certain number of the water molecule. These are called hydrated salts, and this is called water of crystallization. What is meant by water of crystallization? Water of crystallization nothing but the number of water molecules present in the given unit amount of salt is called, or 1 unit of formula of salt. Okay, the number of water molecules present in the given unit formula of salt is called water of crystallization. If you take the sodium carbonate, okay, one molecule of sodium carbonate contain how many water molecules? 10 water molecules. If you take the copper sulfate, 5 water molecules. Calcium sulfate, 2 water molecules. Magnesium sulfate, 7 water molecules. FeS for iron sulfate, 7 water molecules. Now what is this name? This is called washing soda. You know that. Washing soda. And this name is copper sulfate. Copper sulfate. This is copper sulfate. Pentahydrate. Full name is copper sulfate pentahydrate. Sodium carbonate decahydrate. Copper sulfate pentahydrate. Calcium sulfate. This is called two notes. Two is called bihydratic acid. This is called simply another name is this is called gypsum. Gypsum. The general name of this CaSO4 is called gypsum. Next, magnesium sulfate 7H. This is called Epsom salt. Epsom salt. General name is Epsom salt. FeS4 7H2O. Ferrous sulfate heptahydrate, like that. Okay, these are the hydrated salts. Now my question is here. These salts contain water molecules. Now this salt crystal is dry or wet? If you take the copper sulfate, when you touch it, how you feel? Dry or wet? You feel dry only, not wet. Okay. Now where are the water molecules? Let us see that. Okay. Now for that purpose, take a test tube. Take a test tube. In this test tube, take an amount of copper sulfate, CuSO4 5H2O, copper sulfate. Okay. Now heat this with Bunsen burner. Before heating, the color is blue color. Before heating, color is blue color. When you are heating, the blue colored copper sulfate turns into white color. And during that heating, you will observe that there are some drops, water drops. You will see that walls of the inside the wall of the test tube. The water is coming out. When you are heating, water comes out. Now the color of the salt is changing, blue to white color. You see here so many water drops. Okay. Now, so it became white color. Then add one drop into this. Again, it will get the blue color. Very, very important activity. Again, blue color. That means the color of this salt due to water molecules only. Based on the number of water molecules, the salt is getting its own color. So here different colors are there. This is the white color, this is the blue color, this is also white color, this is magnesium sulfate white color, ferrous sulfate is green color. Like that, different colors are there now. These colors is due to the water molecules. This is called water of crystallization. And the last my topic is plaster of Paris. Plaster of Paris. How to prepare the plaster of Paris? First, plaster of Paris formula. Plaster of Paris. POP. Formula CaSO4 of H2O. In one molecule of calcium sulfate, one molecule of calcium sulfate contains how many water molecules? Only half water molecule. Is it possible to make that half water molecule? No. Actually, we have to take like this. Two CaSO4 H2O. One H2O. You can take that one H2O. Generally, actually formula is CaSO4 half H2O. But half is not possible, no, that's why two calcium sulfate sharing one water molecule. I am water molecule. This is the calcium sulfate, this is the calcium. These two are sharing me. That's why, but if you want to write the formula, CaSO4 half H2O, that is called calcium sulfate hemihydrate. Okay, calcium sulfate hemihydrate. This is the plaster of Paris. Okay. Now, how to prepare the plaster of Paris? Now, first to take the gypsum. Gypsum formula already we studied. Calcium sulfate 2H2O. This is the gypsum formula. When you heat this at 100 degrees Celsius, when you heat this at 100 degrees Celsius or 373 degree Kelvins, what happened? One and a half water molecule is evaporated and it gives that CaSO4 half H2O and one and a half water molecule is evaporated. Now we will get that calcium sulfate hemihydrate. This calcium sulfate hemihydrate we have to preserve in airtight bags or airtight containers. Why? Because when it exposed to water, when it exposed to moisture, immediately again you will get the gypsum. Again you will get the gypsum. Got it now? Okay. That's why we have to preserve this plaster of Paris in airtight bags or airtight containers. Okay. Now what are the application of this plaster of Paris? Number one, doctors are using to set the bones. Okay, to set the broken bones. Doctors are using the plaster of Paris. Okay, and second one is to prepare the idols, to prepare the toys, in decoration of ceiling. These are all the, okay, for decoration purpose we are using the plaster of Paris. What is the color of the plaster of Paris? Pure white color. Pure white color. Okay, so this is about the plaster of Paris. Thank you.